Hello guys, this is Paul McWhorter with TopTechBoy.com, and we're here today with episode number 14 in our incredible new tutorial series where you're teaching your Raspberry Pi who's the boss. Now what I'm going to need you to do is pour yourself a nice tall glass of iced coffee. That would be straight up black coffee poured over ice. No sugar, no sweeteners, none needed. And as you're pouring your coffee, as always, I want to give a shout out to our friends over at Sunfounder. Sunfounder is actually sponsoring this series of video lessons. And in these lessons, I will be using the most excellent Sunfounder Ultimate Raspberry Pi Kit. Now, hopefully, most of you guys already have your gear, but if you don't have your gear yet, look down in the description. There is a link over to Amazon where you can pick up this most excellent kit. And believe me, in this class, your life and my life are going to be easier if we are working on identical hardware. So if you don't have it yet, skedaddle on over there and get your gear ordered. But enough of this shameless advertising. Let's talk about what I am going to teach you today. And what I'm going to teach you is I'm going to teach you how to install Vpython on your Raspberry Pi and how to start out by making a very simple 3D model, a very simple 3D animation of what we were doing, the project that we were doing in lesson number 13. Now, I did warn you guys to not take your circuit apart in lesson number 13 because we're going to start today with the circuit and the code that we had ended up with in lesson number 13. Now, go ahead and admit it. I know one of you guys didn't listen to me and took the took the circuit apart. So go ahead. I know you're out there. Leave a comment down below. It was me. I was the guy that took my circuit apart, even though you told me not to. There's always that one guy, right? There is always that one guy. But in case you guys need just a little reminder, this is the circuit. This is the circuit I believe that we ended up with. And give me just a second. I need to do a quick little Windows management thing here. Get everything up to date, and then I will move out of your way. Okay, I think that looks good. And so this is the circuit that we ended up with in lesson number 13. You can see that we got 3 switches, 3 toggle buttons, a red, a green, and a blue. We have an RGB LED over here, and we can control the color of that RGB LED by subsequently pressing red and green and blue buttons, and then we can mix together all types of different colors. Okay, so also just in case you guys have lost your code, you can go to the most excellent www.toptechboy.com, and I need to switch over there to that view now. You guys can do a screen capture here of this circuit if you don't have it, but let's go over to the most excellent www.toptechboy.com. Okay, and that let's see, guys, give me just a second. I want to make sure that we are ending up with the same view here. Okay, I think that's I've got to adjust that. That is just not quite right. Okay, there we go. So you go to the most excellent www.toptechboy.com, and then using this happy little search icon here, you can search on something like Raspberry Pi Lesson 13, set the color of RGB LED with push buttons, search on that, and you should come up with this. And then here I have that code that we ended up with in lesson number 13, so I will copy that. And then we can come back to our terminal, and we can create a new program to paste that into. And so remember, we are working in the Python folder. And so I can just create a new program with nano. And let's see, it would be in Python. And then let's just call it RGB, and then dim, and then Vpython, because we're going to put the Vpython in there, and then .py. And here we are. Now I will come over and I will right mouse click and I will paste that code in there. I will control X and a Y for yes, and then enter, and now it should all be in there. Now let's just see if we run this thing. Instead of doing a nano, we will Python 3 it, and then boom, it's running. And now if you keep your eyes on the LED here, if I press red, you can see it turns on very dimly red. If I press blue, now blue and red are on to give me a very dim purple. And then I can step up red or I can step up blue to get various shades of purple and pink and various shades of magenta. And I can just play with those buttons and I can mix any color that I want. But we learned all of that in lesson number 13. And so I'm just kind of reminding you of where we were in lesson number 13. Okay, now what we want to do is, just like I have a real LED, I have a real LED here. I want to create now a virtual LED, and I'm going to create the virtual LED using Vpython. So how do we get Vpython on the Raspberry Pi? I remind you, I am on the Buster operating system, and I am on Python 3.7, which comes with Buster. Now, as I go back and read comments on videos that I make, the number one issue is for you guys that jump in and just watch one of my individual lessons and not taking the whole class and working on a different operating system and a different version of Python and a different this and a different that. And then what I show here doesn't work. For these things to work, you got to be on the same operating system I'm on, Buster, and you got to be on the same Python 3.7, which comes with Buster. All right, but enough of that disclaimer stuff. Let's have a little coffee. And now what we want to do is we want to do pip install, right? Wrong. No. Pip would install it in Python 2 likely. So we've got to make sure we tell it we want it to be in Python 3. And so we do that by saying pip3 install. And then what do we want to pip3 install? Vpython, like that. Everyone hold their breath. We want to see like it finding things going out. Okay, looking. That looks good. Okay, we're getting some little suggestions and stuff there, but so far, all right, that's what we want to see. You see the happy little bar going across. It found the Vpython package. It is downloading it. It is going in and putting it in. It is doing different things. It's pulling it up. Yours might look a little different. You see that I'm seeing a lot of things that say, let's see. It looks like some of this stuff was already installed, and so yours is going to look a little different. But what you should be doing is you should be seeing things going across, and you should be seeing things download and so forth. And so let's see if that actually worked for us. Yours might take a little bit longer because it looked like, because I always practice these lessons before I do them in front of you, and so it looks like some of these things were already downloaded. So yours might go a little bit slower than mine just did. But let's type Python 3. Okay, and then let me get further out of your way there. Okay, and now let me just say import Vpython like that, and we got an import successfully. I think this also probably installs NumPy for you, and so let's just see if we got NumPy as well for free. Yeah, it looks like we got NumPy as well for free. So when you install Vpython, it installs some other useful libraries for you. And so that looks good. And let's just for fun see if we can do our first little Vpython animation. And so what I am going to say is I'm going to say make a ball, and the ball is going to be equal to a sphere. And that sphere is going to have a radius equal to 2 arbitrary units. And then the color is going to be equal to color dot red, like that. And then, ooh, sphere. Okay, what did I do wrong? Sphere, that sure looks right. What did I do wrong? Oh, yeah. Okay. What I need to do is from Vpython import star. What I did was I just imported it to see, you know, is it there? Yeah, it was there. But here, this way, I don't have to type Vpython every time I want to use the Vpython library. And let's see if this will work now. And so now we're going to say ball is equal to sphere, radius of 2, color is equal to color dot red. And we are holding our breath, and Shazam! Look at that! We got a red sphere in 3-dimension, and we can come in with our mouse and we can kind of go up and down and do things like that. You know, I'm scrolling with my center scroll wheel, and I can zoom in and zoom out. But let's kill that. Okay, and then let's get rid of this, and then let's come over here and let me do it one more time. I'll say Python 3, okay, and I am going to say from Vpython import star, which means import everything, and now I'm going to say my box is equal to what is that? That will be a box, okay, and the box is going to be what? It is going to be color equal color dot blue, and then the length is going to be equal to 3. The width is going to be equal to 2, and the height, height, H-E-I-G-H-T. That's a hard word to spell. You guys know that? That is a hard word to spell. Let me see if I can bring this up to make sure you guys are seeing it. Okay, I think you can see that good. Height is equal to 1, let's say. All right, so this should make a box. Boom, okay. Now what you can see is I can back away, and then I can right mouse click and spin it, and you can see that box I made. So you see we are making 3D animations using Vpython in the command line, and that is pretty neat. Okay, but what we want to do now is, instead of just doing that, what we actually want to do is we now want to start building something inside of that other program that we had. And so what we're going to do is we're going to go back and see if we can nano that RGB dim vpython.py. Okay, that looks really good. And what we're going to want to do to that program, we're going to want to start by saying from Vpython, we want to import star. Okay, now we're going to go ahead and do all of our button work and all of our GPIO work and all of that good stuff. Okay, and then here what we're going to want to do is go ahead and let's just make a sphere. And so I'm going to say, I'll call it my sphere is equal to a sphere, and then the color is equal to color dot white. I think it'll do white, and then the radius is equal to radius is equal to, let's just say 1. Okay, so this should make a white sphere, and then everything else should be okay. Then inside of this loop, we just, sometimes Vpython wants a rate statement, and so I'll just say rate of 20, which means you could do this at like 20 times a second. Now we've got some other things in there that are going to determine how fast it actually runs, but you just, sometimes Vpython wants to see this rate statement. So now I'm going to go Control X, yes, enter, and now we'll get it to do some interesting stuff here in a minute, but let's just see if we can, that was unexpected. Oh, okay. Okay, we don't want to just Python 3, we want to Python 3 the program. Okay. Man, you guys can't see that. We want to Python 3 that program that we just created. How about that? Okay, you can see that now. So we're going to Python 3 that program, and then it doesn't like the indentation, and so let's see what we did wrong there. That was inside the while, inside the try. Wow, that sure looks right. Oh man, you know what? I think when we cut and pasted, I think it did a very terrible thing, which is it put spaces instead of tabs. And so if you're having this problem, you're going to have to space over like that. And I will have to figure out how to fix that, but this is the first time that I've copied from toptechboy.com and pasted into Nano, and we got an unexpected result there. So I'll get to the bottom of it, but I think we can power on through this lesson. So let's go in and let's run the program again, and this time, okay, it comes up and we get a sphere, we get a white sphere, and the program here is still working, okay? Now nothing's happening to the ball because all we did was we just created the ball, okay? We just created the ball. So we will kill that, and then we will come over here, and when we killed that, it seems like it killed the Python program, which is okay. I guess I should probably Control-C to cleanly, so I shouldn't kill that graphic. I should cleanly kill it over here with Control-C, but let's nano it again. Okay, and here we go. We're going to come down. Now what would be very, very interesting for me to do inside of this while loop, okay, and that is after I do all of these if statements, okay, and then when I'm ready to, before I sleep, and remember you got to scoot over now with the space bar because it's using spaces instead of tabs, okay, and same thing here. I need to space over. I need to say my sphere.color is equal to what? It's going to be equal to a vector. And what you could imagine is I want to give this color a red component, a green component, and a blue component, just like I gave the LED here a red component, a blue component, and a green component using these buttons. Well, where are those levels stored? They are stored in the variable DC for duty cycle for blue, DCG for duty cycle for green, and DCR duty cycle for red. And the duty cycles go between what and what? They go between 1 and 100, or between 0 and 100. Well, 99 really, but we're not going to worry about the difference between 99 and 100. So if I wanted, but you see the problem is Vpython wants its color range not from 0% to 100%, but between 0 and 1. And so if I want to apply the R, like if you think the R, the G, and the B to that animation that I just made, the R, the G, and the B, what would that be? That would be DC little r, DC little g, and DC little b for duty cycle red, duty cycle green, and duty cycle blue. All right. But now what's the problem? These numbers are between 0 and 100, and we want a number between 0 and 1. So what do we really want to do here? We want to divide by 100. We want to divide by 100, and we want to divide by 100. And that takes the numbers that the GPIO pins and pulse width modulation and the LED in the real world and turns them into the scale wanted by Visual Python. So let's Control X out of here. Let's yes, and then let's enter. And now let's run it again. Python 3. That looks good. Let's run it. Whoa, okay, yeah, so why did I get that error message? I got that error message because I hadn't cleanly exited. I exited by killing the graphic, and then it crashed the program, and I never did the GPIO cleanup. Okay, now let's think about it. I have now a black LED up here. Why do you think it's black? I set the color to white. Why is it black? It's black because right now this LED is in effect black because there's no red, there's no green, there's no blue, there's no color in the real LED, and in the virtual LED there's no color because I applied what? DCR, DCG, DCB divided by 100, all three of those numbers would be 0. So what am I getting? A big fat 0. Now this is the moment of truth. If I press this red button, what two things should I see? The two things I should see is this should get very dimly red and I should see something up here happen. Okay, and I did get very dim red here, but I see almost nothing happening there. And so let's see if we bring it on up, what we will get. Okay, it's just this one in the real, the one in the virtual world is turning red a lot more gradually. Okay, and so they aren't calibrated perfectly. Okay, but do you see, and let me see if I can show this. I'm trying to show a lot of different stuff at once. And so you can see the red strength is at 60%. And now the red strength is at 90%. The LED is almost completely red. And then when I go again, then they both turn off. Now what you can see is that these aren't perfectly calibrated, in that you can see in the real one a little bit quicker, you can see it turning red. And the red in the virtual one is really not quite, it's not quite perceivable. And so let's see what we could do there. What if I'm going to be smart this time? I'm going to come over here and I'm going to Control C here, and then that cleanly exited the program, so that's good. And now what I'm going to do is I'm going to nano the program. And I think maybe what we could do is I would have to think about how to, I wasn't really expecting that result, so I would have to think about how to normalize those better. But maybe instead of divided by 100, maybe it would normalize it better if I divided by 10. Because I think what's happening is the real LED is more on an exponential scale, and the virtual one is more on a linear scale. And so I'm going to try to have that color come up quicker here, and we might get a little smarter about this in a minute. So let's say Control X, yes, enter. And now I'm going to come up with Python 3, and I wouldn't have expected the error that time, but we're still getting it. Okay, so now what I'm going to do is I'm going to come over here and press red, and yeah, I'm getting a perceptible red right off the bat, and now it's perceptible, and then it's coming on up, and then it's coming on up. Okay, you see they're kind of matching better there, I think. Okay, and then that's like really bright there. And then they both go back off. Now let's see if we do the red and the blue. You see we got a very faint purple there, and we're bringing the purple up virtually, and we're bringing the purple up in the real world. Okay, and so that is pretty clear. That's pretty slick. Okay, so now let's come back over here. You can see that it's kind of working, but what we got to think is I just Python 3 nano. Okay, you see that what is happening now is I need to do something better. If I divide by 10, then it works on the low end, but then at the higher end, it begins to saturate. At the higher end, it begins to saturate too quickly. So I can have it working on the high end, I can have it working on the low end, and I need to so I divide by 10. I'm just trying to think. I think I need to like take the log of this, but to get it to work more perfectly, what I'm going to do is I'm just going to divide by 25, and then it'll work a little bit on the low end, it'll work a little bit on the high end, but we need to figure out how to more perfectly get this thing calibrated. We need to figure out how more perfectly to get the calibration working at the low end and the high end, but maybe 25 would be a good compromise at this point. Yeah, I think that'll be a good compromise. But one thing is, you see that here I've got an LED that is a complicated shape, and all I made was just a sphere. And so what if we came up here, and besides my sphere, if I made my cylinder, and my cylinder is equal to cylinder, and the color equal color.white, and the radius is equal to 1, okay? And then if I'm going to do that, then what I'm also going to do, let's just look at that and see what happens when we run it. So I'll say Control X, yes, enter. Let me do one more thing there, Python 3 nano. Let me also down here, let me change its color. When I change the color of the sphere, what I'm also going to do is I am also going to, here I'm also going to say my cylinder.color is equal to vector, and I'll do the same thing, dcr divided by 25, comma, dcg divided by 25, comma, dc blue divided by 25. Okay, and now Control X, yes, enter, and now we'll come and we will Python 3 it. Okay, and so now I'm going to turn on the green. Okay, I'm going to turn on the green, and you can see that I got a little green, and then I'm going to turn on the blue, and I'm getting a little blue, and I'm bringing up green and blue. Okay, and I'm getting a very beautiful aqua here. I'm getting a very beautiful aqua in the real world, and I'm getting a very beautiful aqua in the virtual world. And so that looks good. Now, what do we not like about that? We don't like that the cylinder came out this way, and what we want is we want the cylinder to come out this way, and then we want the sphere to be moved up. So that's two things that we need to do. We need to move the sphere up. Okay, we need to move the sphere up, and we need to turn the cylinder up. And so what we're going to do is we're going to come in here, and when we create this cylinder, we are going to give it an axis. Which direction do we want it to point? Well, we've got to remember that X goes this way, okay, Y goes this way, and then Z comes out. So you go from X to Y, and your thumb points in Z. And so the first, it's kind of like X, Y, Z. So we need to give it an axis. Do I want it to point in the X direction? No, I put a 0. Do I want it to point in the Y direction? Yes, I do. So I give it a 1. And then do I want it to point out in the Z direction? No, so I give it a 0. All right. And so that should pop that cylinder pointing upwards in the Y direction. And then the sphere, if let's see, I need to give a length. I need to give a length to the cylinder, and so I will say length, and let's say the length is 1.5. So it's going to be a little taller than it is across. But wait a minute, radius would be, it would have a diameter of 2. So we would want the height to, be like 2.5, like that. Okay, and so now it's going to be standing up. It is going to be a little bit taller than it is wide. All right, but now if we do that, we need to move this sphere. We need to move this sphere up. And so how far would we want to move the sphere up? We would give it a position, and the position would be a vector, and we're going to give it an X value, a Y value, and a Z value. Do we want it to move in X? No. So we give it a what? A 0. Do we want to move it in Y, the sphere? Yes. We want it to go up how far? 2.5. Do we want it to move in Z? No. We give it a 0. Okay, then we'll close that out. Control X, yes, enter. And now we are going to Python 3 it. And what on earth? Did I misspell axis? What did I do wrong there? Okay. Positional argument follows keyword argument. Oh, I know what I did wrong. Okay, I know what I did wrong. It should be axis equal vector. I was not thinking. Just like I said, position is equal to vector here. I needed to say axis equal vector like that. Now we're going to do Control X, yes, enter. And now let's see what happens. Everyone hold their breath. Still getting the warning. Okay, boom, look at that. Let's start bringing some color up here. Let's bring it up as a purple. Okay, let's bring it up as a purple. Wow, that's starting to look like an LED. Okay, so look at this. What if I kind of lay this over a little bit? If I lay this over a little bit, you can see color LED in the real world, color LED in the virtual world. Okay, now if you look at your LED, how could I make this a little bit more realistic? Do you see the bottom of the LED has a little bit of a disk? Why don't we put that disk in there? So I'm going to come over here and I'm going to do a Control C. Okay, Control C. All right, so now let's nano this thing again. And if I want to make a disk, what would I do to make a disk? I need another what? What would I need? I need another my cylinder, but I'll call it my base. Okay, and that is going to be a cylinder, and the color equal color dot white. The radius, do I want it the same radius as the body? No, because then it wouldn't show. I want it a little bit bigger. So I'll say radius is equal to 1.2, like that. And then what would the length be? I want a little guy. So I'll say length is equal to 0.25, so it'll be like 10% of the height. And then I've got to point, it would be a disk like this. I've got to point it up, so I give it a what? An axis equal vector, and then what? 0, 1, 0, 0, 1, 0. Close the vector and then close the... You guys cannot quite see that, can you? Let me make sure that you can see this. Okay. No, that's not good either. You see, Nano doesn't like these long lines. Okay, so I will have to figure out how to fix that better for you, but just know that you've got to close the vector here, and then out here there is another close to close the cylinder. All right, and so hopefully that will make sense. So now let's control. What else do we need to do? I was fixing to Control X out of here, but then what do I need to do down here? Down here I need to... Okay, down here I need to say my base dot color is equal to a vector, and then the same thing, dcr divided by 25, comma dcg divided by 25, comma dcb divided by 25, like that. Okay, Control X, yes, enter. And now let's run it and see what happens. And, oh, I see. I put a dot instead of a comma. Simple mistake. Where was that? Down here. Yeah, I hope you guys saw that. Okay, comma, Control X, yes, enter. And now let's run it, Python 3. Okay, still getting that old, annoying. It's like the one time I didn't clean it up. Now it's not letting me clean up. I would probably need to reboot the Pi, but I don't want to do that. Okay, did we get something? Let's go red and green this time. So we're going to kind of be bringing up a yellow. Shazam! Look at that. Is that cool or what? Is that cool or what? That this thing is doing whatever I do in the real world is being mimicked in the virtual world as far as matching those colors. Okay, now if we were really going to just, I think that I've got a little bit of time. So if we were going to do one more thing, what would we want to do here? Now this is strange because I'm doing a Control C, but I'm not getting that GPIO good to go. You see, for some reason in my try and accept, it's not coming down here except keyboard interrupt, which is the Control C. Try. It's not jumping down there correctly, but I'll get it figured out. Maybe I'll have a supplemental lesson later on, but the main learning you are getting here, and the main learning that you are supposed to be getting, is how to build this thing. So let's say, what if I now made the legs? Let's see if I could make the legs of the LEDs. Okay. Let's just say my leg 1 is equal to a box, and the box should be I'm going to give it a size instead of length and width and height. I don't want to do that because what's length, what's width, what's height, I don't know. And so, you know, like I don't know which way it's oriented. So I'm going to make the size, equal to a vector. And I know in X I want it to be very small, so I'll say 0.1, and in Y I want it to be long, and so I'll say that it's like 1, and then in Z coming out it would be 0.1, so I'll make it 0.1, and then I will say color equal color, let's see, I'll make it a vector. I don't know if gray is considered a color, so I'll make it a vector, and I will just say it's 0.2, comma 0.2, comma 0.2. And if I make RGB the same, then it should kind of turn to white, but I didn't go to 1, so it should be, you know, it should be a gray. Okay, what I don't know is if I need to pop that thing up, but let's see what happens if we just run this. Control X, yes, enter, and then we are going to nano that thing. Nope. We should Python 3 that thing. Okay, so that is kind of interesting. It looks about the right size, but I need to move it down. Okay, I need to move it down, and I need to make it longer because it's putting the center at the origin, and I need to move it down. So I am going to come back over here and Control C, and then I'm going to nano that. All right, and I am going to come down here. My leg 1, and so that I think is a pretty good size, and I'm going to need to give it a position. So what I'll do here is I will say position is equal to vector, and then what do I need to do is I'm going to make the height 2. Okay, so that leg is going to be in the Y direction 2. Is that good? Well, then I need to move it down by, I need to move it down, and so also I'm going to need to move it in X, right? I'm going to need to move it a little bit in X to the left because the pin isn't coming straight down from the bottom. So in X, I'm going to need to move it by oh, let's say 3/4 of the radius. And so I'm going to move it to the left by minus 0.75. And then I am going to move it down by 1 because that's half of how tall it is. I'm going to move it down by 1. X positive is up, X negative is down. And then in Z, I don't want to move it. Okay, like that. Control X, yes, enter. And now let's Python 3 this thing. And I put some sort of mistake in there. I got like an extra parenthesis, it looks like. How did that happen? That parenthesis probably goes somewhere. Okay. I always hate taking a parenthesis out because usually it actually belonged in there somewhere. Okay, so let's Control X, yes, enter. Let's run it. And I got an error, and that's why it didn't go on. So position is equal to vector. Size is equal to vector. Color is equal to vector. A vector. I didn't put in the third component. Okay, I see. Do you guys see what? I didn't complete that correctly. So we're going to nano it, and then we're going to come down here. And somehow it didn't get that 0. You see I put a comma and that needs a 0 in there. So now Control X, yes, enter. And now we will Python 3 it. We get our old friend the error message. Okay, look at that. That looks pretty good. And now I'm going to start turning it red. Okay, that looks really good. Okay, that looks really good. Now what we will do is we'll come over here, Control C, enter. And you can see that that really needs to be quite a bit longer, that was too short. And so that leg, we would want to make that leg longer than that. And really, if you think about it, the leg is way longer than the thing is tall. And so where we made the size, we made it a 2. That should really be like a 6, okay? And then we still need to move it down by half of 6, which would be 3, like that. Control X, yes, enter. And now we will run it and Shazam! Look at that. Watch this. We'll bring it up blue, and I'll try not to cover up. Okay, you see as it's getting blue in the virtual world, it is getting blue in the real world, and then we come up to like maximum brightness here in a second. Okay, and then it goes and it wraps back around. Shazam! That is pretty darn neat. Let's see if we can get that beautiful aqua color again. Okay, coming up and getting the beautiful aqua color. All right, guys, that is pretty slick. Okay, like I say, my goal here was not to make you a visual Python expert in one lesson, but you can see you can control the color, you can control the orientation, you can control the position, and you can make a sphere, you can make a box, or you can make a cylinder. And with that, you can do some pretty incredible stuff. Okay, now this is your homework assignment. I think that was pretty cool. I think that was pretty cool, but we do need to talk about your homework assignment. Okay, we got a couple of things that I need to think through a little bit, and that is how to better orient the color so that the color matches, the hue and the shade match better calibration between the virtual world and the real world. But what I see is that your eye perceives color in the case of the real world LED, logarithmically. So we had to increase the color, the intensity by a factor of 2 with each button push. Okay, but that doesn't work very well in the in the virtual world, that maybe it would have done better with a linear increase. And so I got to think a little bit about how to get the color to more perfectly match, just because I'm a perfectionist. But what your homework assignment is to go in and to continue to build out your LED, because what did we end up with? We ended up with one leg on the LED. So I want you guys to go ahead and build out your model more completely. And then what I want you to do is post your solution to YouTube. So post your solution to YouTube. In the description of your YouTube video, leave a link back to this video. And when you leave a link back to this video, then people will have context when they're looking at your solution. And then down below in this video, leave a comment, I am legend, and then leave a link over to your homework solution. And let's see who can be the most OCD and over the top in their simulation. Like, you could imagine that you could do the simulation, the Vpython simulation of the LED by including 4 legs, and all 4 legs are not the same length, so you could kind of do things that way. And you might even think about, could you have just like something maybe for the breadboard and the buttons? I mean, just how many components with what we've learned so far, which is you can make a sphere, you can make a box, and you can make a cylinder. How much of this could you do in creating a simulation of this in Visual Python? All right, guys, man, I hope that you're having as much fun taking these lessons as I am making them. I think it's just really cool to be bringing together programming on the Raspberry Pi with real hardware, which are our buttons and our LEDs, and then having a simulation or a model of that on the Raspberry Pi using Visual Python. You see, we're bringing together a lot of different and really cool stuff. Guys, as always, I want to give a shout out to you all who are helping me out over at Patreon. It is your support and your encouragement that keeps this great content coming. You guys that are not helping out yet, think about looking down in the description. There is a link over to my Patreon account. Think about hopping on over there and hooking a brother up. And also, you really help me if you'll thumbs up this video, if you'll leave a comment down below, if you'll subscribe to the channel, share this with other people, because the world needs more programmers and engineers and fewer people sitting around watching silly cat videos. Paul McWhorter with TopTechBoy.com. I'll talk to you guys later.